In this episode, we're going to build a beginner-friendly understanding of cloud identity and access management, IAM, but we're going to do it in a way that treats least privilege as something you maintain over time, not something you set once and forget. Many learners think IAM is mostly a vocabulary test about users, roles, and policies, but the real skill is understanding how access works as a system that changes every time an application is updated, a new service is adopted, or a team's responsibilities shift. Least privilege is often described as a principle, which can make it sound like a nice idea, yet in cloud it is one of the most direct controls you have against major incidents. If an attacker steals credentials, abuses metadata, or compromises a pipeline, IAM is what determines how far that compromise can spread. Our goal is to help you see IAM as a living system, designed deliberately, monitored continuously, and adjusted responsibly. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Start with the simplest definition. IAM is the set of mechanisms that determine who or what can access which resources and what they are allowed to do. The who can be a human user, a service account, or a workload identity, and the what can be a resource like storage, compute, databases, or management functions. In cloud, nearly every meaningful action is performed through an API call that can be authenticated and authorized, which makes IAM central to everything. Authentication is the process of proving identity, while authorization is the process of deciding permissions after identity is known. Beginners sometimes mix these together, but separating them helps you reason clearly. An identity can be authenticated correctly and still be dangerous if it is authorized too broadly. Now let's talk about the building blocks, because Cloud IAM is built from a few concepts that repeat across providers even when the names differ. Identities represent actors, and actors can be humans or services. Policies represent rules that grant or deny actions, often tied to specific resources. Roles often represent sets of permissions that can be assigned to identities or assumed temporarily, and groups can collect identities for easier management. Some providers also use the idea of bindings or assignments to connect identities to roles or permissions, which is just another way of expressing who gets what. The key is that these building blocks are composable, which means you can design clean, scalable access models, but you can also accidentally create tangled permission webs. A clean mental model is that policies express capability, roles package capability, and assignments connect capability to identities. Least privilege means giving an identity only the permissions it needs to perform its intended tasks, no more and no less. That sounds straightforward, but in practice it becomes tricky because tasks evolve and because people often overestimate what is needed to avoid breaking things. Least privilege is not only about restricting access. It is also about building clarity. When permissions match purpose, you can understand why an identity exists and what it should do. When permissions are broad and vague, you cannot easily tell whether activity is normal or suspicious. Attackers thrive in ambiguity because broad permissions allow them to explore and blend in. Least privilege reduces ambiguity by narrowing the set of legitimate actions, which makes anomalies easier to detect. The reason we call least privilege a living system is that cloud environments change continuously. A team adds a new feature and the application needs access to a new storage path. A deployment pipeline is updated and now it needs permission to push artifacts to a different location. A support engineer joins and needs read-only access to logs for a temporary investigation. Each of those changes can be reasonable, but each also introduces risk if it is done casually. If you add permissions quickly and never remove them, you get privilege creep, where identities accumulate power they no longer need. Privilege creep is one of the most common ways cloud environments become fragile because every extra permission is another door an attacker can use after credential theft. Treating least privilege as living means you expect change and you build routines to keep permissions aligned with current need. A practical way to think about privilege creep is to imagine that permissions are like keys on a key ring. At first, you might have a few keys, and it is easy to know what each one does. Over time, If you keep adding keys for one-time needs and never remove them, the key ring grows and becomes confusing. Eventually, you cannot remember which keys are still needed, and you might be carrying keys to doors you should never open. In cloud, that confusion is worse because permissions are not physical objects. They are lines of policy that can be hard to read and easy to ignore. Least privilege as a system means you regularly remove keys that are no longer needed, and you design roles so keys are organized by purpose. If you do not, your environment becomes a permission jungle that attackers can navigate better than you can. Another fundamental concept is the difference between human identities and workload identities, because treating them the same is a recipe for trouble. Human identities often need interactive access and might be subject to stronger authentication controls, while workload identities are used by applications and automation and often operate without a person present. Workload identities should be designed for specific tasks and should be tightly scoped because workloads are frequently exposed to attack through software flaws. If a workload identity is overprivileged, then a compromised workload becomes a privileged cloud operator, which is exactly the scenario attackers want. Human identities also need least privilege, but they often require a different design approach, such as role-based access for job functions and careful separation between everyday work and administrative tasks. The exam will often imply these distinctions, even if it does not state them directly. You also need to understand how permissions can be scoped, because scoping is how least privilege becomes real rather than theoretical. Scope can be based on action, meaning what operations are allowed, such as read, write, delete, or manage. Scope can be based on resource, meaning which specific resource or group of resources the identity can act on. Scope can also be based on conditions, meaning access is allowed only when certain context is true, such as a certain network location, time window, or device posture. When you combine these, you can create access that is both usable and safe. The weak pattern is permissions that are broad across all actions and all resources, because that creates maximum flexibility at the cost of maximum risk. The strong pattern is narrow permissions aligned to a well-defined purpose. Least privilege also depends on the idea of separation of duties, which means different critical actions should require different identities or different roles. If one identity can both create access and approve access, or both deploy code and change security controls, then compromise of that identity yields a full takeover. Separation of duties reduces single points of failure, but it also reduces accidental mistakes because it forces review. Beginners sometimes see separation as bureaucracy, but in cloud it is one of the ways you prevent a small compromise from turning into a catastrophic chain. For example, an application workload should not be able to modify its own permissions, and a deployment pipeline should not be able to grant itself administrator rights. These are living system decisions because they must be enforced as teams evolve, not just written in a policy document. Monitoring is another part of least privilege as a living system because you cannot maintain what you cannot observe. You need visibility into who is using which permissions, when, and for what types of actions. If you can see that a role is never used for certain actions, that suggests those permissions might be removable. If you see an identity suddenly using new types of actions, that might suggest a compromise or a misconfiguration. Monitoring also helps you detect when an identity is being used in unexpected contexts, such as from unusual locations or outside normal patterns. A living system does not rely solely on design time decisions. It uses runtime signals to confirm that design matches reality. This is where logging and alerting connect directly to IAM quality. Least privilege also requires a healthy approach to exceptions, because real environments always have exceptional situations. If your IAM design makes it impossible to do urgent work, people will create workarounds, and workarounds often create bigger risk than the original problem. A better pattern is to allow exceptions through controlled paths, such as temporary access that expires or elevated access that requires additional approval. The key is that exceptions should not become permanent by accident, and they should be auditable. Beginners sometimes think the safest system is the strictest system, but strict systems that people bypass are not safe. A living least privilege system balances safety with usability by making secure behavior the easiest behavior. For exam thinking, It helps to develop a short way to evaluate any IAM scenario without getting lost in details. Ask who the actors are, separating humans from workloads. Ask what resources they need and what actions they must perform. Ask what boundaries exist, such as environment boundaries or project boundaries, and whether permissions respect those boundaries. Ask how permissions are granted, reviewed, and removed over time, because that is where living system discipline shows up. Finally, ask what monitoring exists to detect misuse and what controls limit blast radius if credentials are stolen. These questions keep you focused on principles that transfer across providers and across question styles. They also help you spot common wrong answers that sound plausible but ignore maintenance and drift. As we close, Cloud IAM fundamentals are about controlling who can do what to which resources, and least privilege is the core safety principle that keeps those controls from turning into broad, fragile access. The reason least privilege must be treated as a living system is that cloud environments change constantly, and permissions that are correct today can become excessive tomorrow. A strong IAM posture distinguishes human and workload identities, scopes permissions narrowly by action and resource, and enforces separation of duties so no single compromise becomes total control. It also includes monitoring and routines for review and removal, so privilege creep does not quietly expand the attack surface. When you understand IAM this way, you are not just memorizing terms, you are learning how cloud access actually behaves under pressure, which is exactly what the exam is trying to measure.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.